Find the y-intercept, if any, x-intercepts, if any, vertical asymptotes, if any, including the asymptotic behavior on each side, and holes, if any, for f of x equals x divided by x plus 8. The first thing to find is the y-intercept, where the function crosses the y-axis, defined by x equals 0. The corresponding y-coordinate will be the function evaluated at 0, so we will plug 0 in for each of the x's, giving 0 divided by 0 plus 8, which is 0 divided by 8, and 0 divided by any non-zero number is 0. The x-coordinate was a 0, the corresponding y-coordinate was found to be 0. The y-intercept is 0, 0. The remaining parts are found by taking the function, completely factoring the numerator and the denominator. There's nothing that can factor. And then canceling any common factors. There's no factors that can cancel. The x-intercept, where the function crosses the x-axis, defined by y equals 0, can be found by taking the leftover numerator and setting it equal to 0. It looks like the x-coordinate is 0 and the corresponding y-coordinate is also 0. There's the x-intercept. The vertical asymptote is found by taking the remaining denominator, setting it equal to 0. Solving for x, and it looks like x equals negative 8 for this one. We will want to look at the asymptotic behavior on each side, which means to look at the limit as x approaches negative 8 from the left side, indicated by the negative superscript on the negative 8, of x divided by x plus 8, and the limit as x approaches negative 8 from the right side, indicated by the positive superscript on the negative 8, of x divided by x plus 8. Let's start with the left-sided limit. Approaching negative 8 from the left side means more negative than negative 8, like negative 8.01. If that were plugged in for what is making 0 in the denominator, negative 8.01 plus 8 will be a negative number. It will approach 0, and therefore we can replace it with a 0 and a negative. Since it's negative 8.01 added to 8, it will be a negative number the entire time. Now negative 8 can be placed in all other x's in the numerator. That will be a negative 8. Negative over negative can be canceled to become positive. Non-zero over 0 is an infinity, and it limits to positive infinity on the left side. The right side can be analyzed in a similar fashion. The right side of negative 8 is less negative than negative 8, like negative 7.99. If that were plugged into the denominator where it's making 0, the x plus 8, negative 7.99 plus 8 is a positive number. And therefore x plus 8 can be replaced with a positive 0. Negative 8 can plug in for all remaining x's, giving negative 8 over positive 0. Negative over positive will be negative. Non-zero over 0 is an infinity. And on the right side it approaches to negative infinity. There's the asymptotic behavior on each side. The last thing to determine is any holes. Holes occur when there are factors in the numerator and denominator that cancel out completely from the denominator. There was nothing in the original function that was able to cancel, so for the holes there will be none.